My name is Xingting Yu, and I consider myself like a planetary and exoplanetary scientist, studying mostly the hazes in planetary atmospheres. And I do mostly laboratory experiments to understand how clouds and haze form and how do they affect large-scale processes on planetary bodies. Yep, that's it.
All right, Justin, do you want to start with your two questions?
Yeah. Okay, so the first question, are clouds and exoplanets different from other planets? And if so, what makes them different from one another?
So you guys know clouds here on Earth are like water clouds, right? So I mean on other planets in the solar system, like clouds are weird. For example, let's see. Do you guys know Titan? Yeah.
The moon on Saturn, right?
Yeah. Do you guys know what clouds are on Titan?
No.
So you guys heard of like methane? Like it's kind of like water on like Earth, right? So basically methane is kind of the water on Titan. There's like methane clouds and even like other hydrocarbon clouds, like methane, stuff like that. So basically I would say clouds, anything that is in the atmosphere and can condense into like either like a liquid or solid. And the difference for like clouds in exoplanet is that some exoplanets like just extremely hot. They're like much hotter. Maybe seeing a good example in solar system would be like Venus. So Venus has like sulfuric acid clouds because it's just like crazy up there. And for exoplanets, like some of the stuff that people predicted is like some mineral clouds like KCl or like ink sulfide, even like silicate or like iron clouds. If you go to like crazy temperatures, like maybe 3,000 kelvins. So I would say like, I mean, they're different in composition, but the physics that underneath how they form, it's basically condensation. There are lots of vapor kind of in the atmosphere, and when they hit a point, they condense, they form clouds. So yeah, hopefully that answers that question.
My question is, could you share some information about the blue haze that surrounds Pluto, if you know anything about that?
Yeah, so I studied a little bit of Pluto haze, but it's okay. Actually, like I think Pluto is like pretty cool. So do you guys know why the sky is blue on Earth?
So like, yeah,
just kind of the why like day by day like sky is really like blue-ish.
I don't.
I mean, like you have to learn like some optics, but it's fine. Like basic idea is like you have like this light with like different spectrums, like visible light from like red to blue, right? And these lights just comes to Earth, and basically what happens is like the red light has like a longer wavelength, while the blue light has like shorter wavelengths. And when they hit kind of the atmosphere, they hit the air molecules, which is like nitrogen, oxygen, right? And so shorter wavelengths light are scattered more efficiently, which means they're kind of just scattered around in the atmosphere so we can see them. That's why we see mostly blue. Actually, I think the idea is like we should see like a purple sky because purple has shorter wavelengths, but I think it's based because of like our eye cannot see like purple as efficiently. So like you could, so I don't know if you've ever seen like people talking about this purple sky thing, but the sky should be purple basically. And same thing like for Pluto. So like the haze is like the sky is kind of blue for Pluto because the aerosols are kind of small. So basically, okay, so like imagine like Pluto is like here and the sun is like there and kind of the spacecraft is like here. So basically the light, because the aerosols is really small, the light just kind of passes the aerosols as if like it does not see it. And then it's similar to like Earth, like because blue light scatters like more efficiently, we see it to be blue. I think that's kind of why it's like a blue haze, but that tells us something about the haze. So the haze is not like a very large particle, so they are very small. They're bigger than our air molecules, but they're like pretty small still.
Okay.
Yep.
And then, so our class is like alien worlds, alien life, and so how does studying haze on exoplanets like help us figure out if that planet could inhabit life?
I would say like there are like two parts of the question. So like one part is like studying the haze is like organic molecule, right? I mean, we still don't know like how life kind of comes into being on Earth. And there's one hypothesis that we used to have like a very methane-rich atmosphere, and there was haze forming. And those organic that form from the haze is kind of the starting point for life to evolve from. So that's why like we would say like haze. Oh, if there's haze, like maybe there's life can start from the organics from there. The other part is like to study haze is kind of, like when the process of forming haze will like require like chemicals to form each other and form some stuff, right? What we found is that, for example, when the chemical reactions are forming the haze, they are actually releasing oxygen sometimes. So people are sometimes saying, oh, if we see oxygen on alien world, it means like there's life there. And that's not necessarily true, because like forming the haze, which does not involve life at all, can like emit tons of oxygen as well. So that's kind of what we call like a false positive. So if we see like oxygen world, and it may not be like life, basically.
Right.
Yeah.
All right. The next question that I have for you, it's kind of multi-part. So I read some of your works and I saw that your favorite moon is one of Saturn's, Titan. Why is it your favorite to study, and what is one of the biggest discoveries that you've made on Titan?
I mean, Titan is like cool, like based on just many reasons. I would say like, like, have you guys heard of like Europa, like Enceladus, like those moons, which are kind of, I mean, those like, I mean, the moons of next stop like space exploration. The reason they are cool is like people are saying, oh, they're like water, they're a subsurface ocean, so there could be like life there. So Titan has a subsurface ocean, but Titan has like most cool things. For example, Titan is the only moon in the solar system with a like atmosphere. So no other, like, I would say, yeah, like no other like moons has like substantial atmosphere. And its atmosphere is really similar to like Earth before, presumably. And there's this active methane cycle. So methane is basically acting like water on Titan. And there's tons of organics, which is the part that I'm most interested in. And I don't know, like lots of like geological process looks like the same on Titan compared to Earth, like the lakes, clouds, and like dunes. I just feel like it has everything basically. It's like a Earth kind of alien setting. And my kind of biggest one of the biggest discovery I found is like, so like I studied the dunes like during my PhDs, and like I kind of used my laboratory measurement to kind of constrain where the sand is like originated, and like what's the process to make the sand particles, based on my work of like measuring the mechanical properties of the Titan hazes. So I found it to be like pretty weak, so it should not be like coming from like a really obviously like a setting where lots of liquids are involved, because Titan's liquids are all concentrated in the polar regions. And I think the sand should be kind of formed where the dunes are located, because they cannot transport like long enough. They're just too weak to do that. So that's just one of the big things about Titan, I would say.
Okay. And then the other thing that I read in one of your papers was about the Titan wind tunnel. So kind of what is that? What discoveries have been made using this machine? And what do you think it could show us in the future?
For the Titan wind tunnel, I would say like basic ideas like, Titan is an alien world, like the atmosphere is like different, it's a little bit denser, the gravity is different, the transporting material is different. So Earth is like mostly silicate sand. I don't know, have you guys seen dunes before? Because I've been to Boise, like I think in the area, and I saw like there's like lots of like sand dunes parks around there, right? I mean, like on Titan, it's mostly like organics. So lots of these things are different. And the idea of Titan wind tunnel is like we kind of like change all these different environmental factors and the materials, and we want to see if like transportation of these sand particles works the same as like the process on Earth. And then we find it to be like slightly different. And I would say like it's not like, I feel like I read a question that feel like it's kind of feels like alive related, but it's not really like life relevant. It's just to figure out basically if physics works the same at a different under different like environmental and material conditions.
Okay.
Yeah, basically that's it.
And my first question is, like, are the sand dunes on Earth like similar to sand dunes on other planets or moons?
I was like in morphology, like they look kind of similar, you know, they're like dunes of like different shapes, and we have all these different kinds. And you know, like scientists can like measure like their spacing and their like height, their lengths, and like lots of things are similar. I was like sometimes we see dunes that are slightly different. So you guys like been to like dunes, right? Do you see those like little ripples that are kind of like overlaying on the dunes,
Yeah.
right? So like for example on Mars, there's this like mega ripples, which are like they look like ripples, but they're just much larger scale. Because you can see them in satellite images, and like people are trying to figure out why they're like mega ripples, while there's no like mega ripples like on Earth. So they're like different in some ways, but I was like they look pretty similar if you don't care about the scale. Yeah.
And then my last one is, like, how are you able to find out about the sand dunes on other planets or moons? Like, how can you like compare their physical properties to Earth's?
That's a good question. So that's why we need like space missions, right?
Mm-hmm.
Because without basically lots of things on the surface, you can't really resolve them, even with like the most powerful telescope on Earth. We have like Keck, which can like, for example, tell us like clouds on Titan, but not really surface features. Basically, we have to see, and a good way to measure those like spacing, height, stuff like that is like a radar. It can do like altimetry, like measure like the distance between the spacecraft and the stuff, and characterize a bunch of like features. So yeah, that's how we know they exist, even like on Pluto. So that's the furthest thing we know. Yeah.
All right. I think that's all of our questions that we have for you for this project.
Okay.
I just wanted to say thank you so much for coming on here and answering our questions and helping us with this project.
All right.
Yeah, thank you.
Yeah, thank you.
All right. Yeah. Thank you guys. Yeah. Let me know if you guys have any other questions or anything. Yep.
All right.
All righty.
We also just want to remind you that we are going to be posting this video. It's not just, he has us posted on YouTube, just so you're aware.
Okay. That should be fine. Yeah. And thank you so much. And have a good weekend, I would say. Yeah.
You too.
Thank you.
Thank you.
All
You
right.
too.
Bye-bye.
Bye.
Bye.